Hello and welcome back to another VMK in the game development series. In this VMK, I'll be showing you how to make your game engine more robust. What we have now is a scene graph that's inside of our game, and we populate the scene graph using the standard techniques by adding nodes and so on. In previous videos, I've showed you some downfalls of the technique that we use to render, and these downfalls include things like if you have transparent objects, certain things will become invisible whenever they're rendered on the screen. And I ask you to sort of look into it and see if you can figure out an answer to this. The problem really resides in the fact that the objects are rendered sequentially. So we start off at the very top of the scene inside of our tree structure, and we start rendering things one at a time. When we hit something that's transparent, we go and render it immediately. Well, that's not the way you're supposed to handle things inside of a game, because what can happen is your objects could be sorted in such an order that you're rendering them in the wrong order. And if you do that, then OpenGL can't calculate the transparencies for your objects properly. And that's why we're seeing what we are seeing in our previous videos, where objects appear to be disappearing even though they're still there in the scene. So in this video, I'm going to show you how to fix this so that you can get all your objects rendered on the screen independent of the order in which they appear inside of the scene graph. We'll begin by going into PaintShop Pro, where I can show you graphically what OpenGL does when it goes to render items on the screen. Okay, let's say, I'm going to draw a top view over here, and I'll draw sort of a front view over here so you can get a comparison of what's happening on the screen. So in our top view, let's imagine we have three items. We have this box here, we'll call this B1. We have this second box, we'll call this B2, and we'll have a third box here, call it B3. So when we're looking at this scene from the front, this way, we should see something like this. We'll have box 3 here, let me erase that, box 3, and then we'll have this box 1 here behind it, box 1, and box 2 is going to be located behind both of these, like so. Now, when OpenGL goes and renders this, actually, let me put some dashed lines here so you can see where the overlapping is occurring. Now, when OpenGL renders this, it depends on which order these boxes appear in inside of the scene. So let's assume that when we go and render this scene, we'll say that we send box 1 to the graphics card first, then we send box 2, and then we send box 3. So, going back over here, what OpenGL does is, let's leave this here and let's work up here at the top. Let's say our screen, initially we clear it, so it's completely blank. We render box 1 on the screen, so the pixels for wherever box 1 is supposed to appear will be filled in with the box 1 color. Then we go and render box 2. Well, because we have the depth buffer turned on inside OpenGL, it knows which of these boxes are closer to our eye. And what it does is, in the screen space, this is the front view here, front, I'll label this here top view, and this is also front. So in the front view, it knows that box 2 is further than box 1. So it goes and renders these pixels here, but it doesn't render the pixels that are overlapping with box number 1, these ones here. It will skip these and not render them because it knows that box 2 is further behind box 1. So it knows that these pixels for box 2 should not be drawn here. So it skips them entirely. So it only draws these pixels here. Then, when we send box 3 to the video card, it knows that box 3 is going to overlap, like so. So because of that, it renders all these pixels here for box 3, and it gets filled in completely. Well, that's great, but what happens whenever we have transparent objects? This technique for OpenGL breaks down because all of a sudden certain objects which should be drawn on the screen are no longer drawn because of the depth buffer. The depth buffer is actually what's making our transparent objects not work properly. Let me go and erase this part here and redraw now what happens when we have the depth buffer working. Okay, let's say that all of these three items now are transparent. Well, what's going to happen? We go and render the first item. So on the screen, again, we're going to fill in the pixels according to what the color of the object is plus whatever's behind it. And initially, the screen is blank, so it's going to be just using the alpha channel of the blank stuff to make this color here sort of translucent and make it look like it's transparent. So it's partially see-through. It's not completely opaque. Then, when we go and render box number 2, again, it's going to render only this part here because it knows that the depth buffer is telling it not to draw in this part because box 1 is closer than box 2. So it skips that part and only renders this part. And this is the first mistake that OpenGL does, because when it draws this part here as being transparent, this part here, which should be containing a different color than this part, never gets drawn to be the correct color. So it actually looks like this part here, which is overlapping with box 1, doesn't have any objects behind it. And it looks like this box, box number 2, doesn't exist down here. And that's because of the OpenGL depth buffer. Now, when we go and render box number 3, what will happen is inside of OpenGL, we have pixels now stored here, and we have pixels stored here. So everything will kind of appear correctly except for where these two places get overlapped. So I hope that makes sense to you. Basically, the problem with transparencies is that the depth buffer is preventing certain objects from being rendered on the screen when they're behind other objects, but when you go and calculate the transparencies, the pixel colors that is the result is dependent on what's underneath. But because the depth buffer is turned on, it doesn't draw those things that are underneath. To fix this problem, we just have to do one thing really, and that's order our objects in such a way that we always render them from back to front with respect to our camera. So in this sense, if we had something like this, box 1, box 2, box 3, we should, instead of rendering them 1, 2, 3, we should really render them 2, 1, 3. If you rendered them in that order, then when we look at all three boxes here, they will look correct, even if they are transparent. None of the objects will look like they've disappeared. So that's what we're going to implement in this video. Now, to begin, I'm going to give you an overview of how we're going to do this. Right now, we have our scene, which I'll just represent like this. We'll have node 1, node 2, node 3, node 4, and so on. We have some arbitrary scene. First thing we need to do is render all of our objects which are solid. All objects that are solid will not have any problems, so we can go and render them completely. So that's rule number 1. Render solid objects. Okay. Number 2. If we hit a certain object inside the scene and we realize that it's transparent, what we're going to do is we're going to create a new container that's going to store that specific object's information so that we can go and render it on the second pass. So in a sense, what we're going to be doing is render objects in 2 passes. The first pass will render solid objects. The second pass will render transparent objects. Now, let's say in our demo scene here, I create these 2 objects to be transparent. So on the first rendering pass, we'll go and render everything that's inside N1 and also everything that's inside N3. N2 and N4 will get dumped into this container. But when we do go and put these 2 items inside this container, we're going to do it in a smart way, because when we place them in here, we want to make sure that on our second render pass, we can go and extract them without doing very much processing. All the processing is going to get done whenever we're going through the render pass on the first time. So we're going to render solid objects on the first pass, and then if we find transparent, then we're going to figure out how far this object is with respect to camera. So we're going to come to here, node 2. We're going to figure out how far is he from our camera. Once we know that, then we're going to use that number to place him inside of this container. So let's say he's of size, I don't know, let's say he's 10 units away. So we're just going to put him inside that container. Then we're going to continue on through, and we find another guy, N4. So again, we're going to figure out how far this guy is with respect to the camera. Well, let's say that this guy is 30 units away from the camera. Well, what we want to do is place him at the top of this container. So we're going to take this guy, move him down, and place N4 at the very top. So as we're placing new objects inside this container, we sort them according to depth, so that the furthest object from us is the very first item, and the closest object to our eye is going to be the last item inside of this list. Then, when we finish going through this render pass on the first time, then all we need to do is go into this container and render all items in container. And because we've already sorted all these items in the container, we don't need to do anything else other than just call the render function for each of these items. So that's going to be pretty easy to do. The trick is, how do we sort these guys while we're going through the first render pass, and how to structure this so that we can do 2 render passes. Because right now our code only supports one render pass in OpenGL. Let's go into C++ now and start modifying the code to see how we can achieve this. Okay, the first thing we need to do is create a way so that we can go into the render calls twice. So we're going to go into our node, and inside render OpenGL we have a Boolean variable here, bRenderSolid. That's odd. That shouldn't be there. I don't think it's something we're using. Let me just double check. Inside node shape we have render OpenGL, and then down here, let's see if we're using this anywhere. We're just passing it in. No, we're not. Okay, so for some reason, maybe in a previous video I was using this, but we're no longer using this value for anything, so we can change this to behave differently now. So going back into node.h, let's rename this to be second pass. Now let's save this, and we need to also change the node shape, be second pass here, which also means inside the C++ file we can rename this to be second pass, and when we scroll down to the next guy here, we'll change this to be second pass. So doing that, we shouldn't have changed anything yet. We just renamed the variable. Okay. Now let's go inside of our scene and take a look at our update. Okay, what we're doing here is we're calling the render and we're passing true. So initially, we're going to be doing our first render, which will be passing false here. So we're rendering on our first pass. So that's what that false parameter is meaning. And then, actually, let's go change our scene so we have something to play with. Inside of the initialize here, I'm gonna, let's see. going to delete all of this stuff and just replace it with some new code. And okay, so here's the new code. I'm not going to really go over in detail what I'm doing here. You can figure it out by yourself now. But basically, I've placed 3 boxes on the screen, 2 sort of, one to the left, one to the right, and another box that's just located straight in front of the other 2. But it's rotated 180 degrees so that its open face, or the side that's transparent, is facing sort of inward rather than on the other way around. Well, actually, let me go into here and draw what I mean. Oh. So what I've done there is the following. I have, if we're looking this way, I've placed 1 box here, another box here, and a 3rd box here. And these 2 boxes have an opening located here, and this last box has been rotated 180 degrees with its opening on the back. Okay, and the other thing we need to go and change is inside of the update. We're currently flashing the boxes, so we can disable this since we don't want them flashing on the screen just yet. Okay, and if we build this and run it, we should be able to see those boxes on the screen. Okay, so there they are, 2 boxes, and then there's the last box on the other side. Now notice when we look through this window, we can see the first 2 on the left and on the right perfectly fine. However, when we go back to the beginning here, we can't see the box in the back through this window, but we can see the box on the right through that window. Whereas when we go look through this window, we don't see either of the boxes. And that's because of the order in which we're rendering these boxes. Because we have transparent objects, they're not being rendered correctly because they're being depth sorted by OpenGL automatically. And everything gets messed up. Well, we can correct that. So, now that we have something to play with, we can go and modify our code so that this parameter, which is now representative of which pass we're going through, is going to determine what we render on the screen. Into nodeshape.c++, we're going to go up to the top here, and okay, let's start making some changes. Okay, now remember, rule number 1 was we render only solid objects on the first pass. So let's see here, we're going to set up the materials, we can leave that, and then if we have a texture, then we set up some texture transform stuff, and then we render. Well, we need to make a check here, and we're going to put it right here. But first thing we need to do is we check to see if the object is solid here, which we should do first. So let's go and place this up here. So first thing we do is check to see if the texture is solid. If it is, we're going to set this variable, and we're going to take this guy out of here for now, and we'll put him down here. And let's see. So if he's solid, we're going to set the object, or sorry, if he's not solid, we're going to set the B object solid to false, and then down here we have the first check. So we're only going to go and render this object if the object is solid or it's the second pass. So on the second pass, we're definitely going to have to render it because we have no choice. But on the first pass, we only render objects that are solid. So that's what this check is going to do. It's only going to let through anything that's solid, so it's going to always let that through, or if it's on the second render pass. And if it does get let through, we're going to go and enable textures. We're going to set this guy, and as a matter of fact, we're going to take this out since we're going to handle the blending in a different location. And we're going to move all this stuff over. And then we're going to render, and then undo that, and then undo the textures. So all of that's going to happen only for solid objects. Now I have to do the same sort of thing down here. So right now, if for instance, we had no texture, but the object was transparent, then we're going to go into here, and we only want to render it on the second pass as well. So we're going to do the same sort of check, see if it's solid. If it is solid, we render it. Otherwise, render it on the second pass. So then we'll go in here. So we'll do that. And because we're taking care of the blending in a different location, we're going to take this out now. Okay? So what those changes should do is actually prevent our boxes from being rendered on the screen. However, our floor, which is solid, should be still rendered. Okay, so that looks fine. And we can just double check to make sure that's working properly by going in here and, oh, where did I go? Scene update, no, scene initialize is where I wanted. And let's see here. Let's just make one of those boxes completely solid so that we can double check that, make sure that we're actually rendering those things on the screen properly. Okay, so here's one box. I'm going to take this texture off of it, which means I'll only have a material, and the material itself has no alpha channel. So that one box should be solid, the other two should be still transparent. And there we go. So I'm still rendering one box on the screen, just the same way as I was doing before. But now when I put a texture on it, because this texture has a transparency, we prevent that box from being rendered on the screen. So now we go to the question of, okay, what do we do on the second render pass? On the first render pass, we'll go through here and only render objects which are solid. Well, what do we do with the objects that aren't solid on the first render pass? We need to make a condition check, and I'll do that right here at the bottom. So we're checking to see if the object is not solid and it's not the second render pass. So in other words, it's the first render pass. If this is true, then we need to go and store this current objects inside of that second container, so that on the second render pass, we can go and render everything appropriately. Now the code that I'm going to show you here is something that you won't find anywhere else on the internet. This is kind of like an exclusive first-time viewing anywhere in the world right here in this video. So tell all your friends if they're having trouble doing this, because it's not very intuitive on how to do this. But it's actually quite simple. Okay. So inside here, what we're going to do is create an object that we can place inside of our container that represents this current object which we're trying to render. Now, when we go and place it inside this container, we're going to sort everything by depth so that on the second render pass, it's easy to figure out how to render things in the correct order. Before we go and do all of that work in here, let's define how this container is going to be structured. We can do this inside of the node_shape.h class. So here we go, right at the top of node_shape.h, I've placed the structure which is going to be holding the current object which is transparent. And the structure is called alpha object, and it contains three things: a pointer to a node shape, a float, and a 4x4 dimensional matrix. The node shape pointer is a pointer to our current node that contains this shape that we're trying to render. But for this alpha object structure to work, we need to define what node shape is. But you'll notice that the class for node shape is located below it. So for the compiler to not complain for this line of code here, you need to make sure you add class node shape above it. And this is called a function prototype or class prototype, because it tells the compiler there is such a thing called node shape, it's a class, and it's going to be defined soon, so that when it gets to here, when it sees node shape, it knows, oh, this is a class. And then when it gets down here, it actually fills in the information for that specific class. So that's why you need this line of code up here. Then we have a floating point number, and this number represents the distance of our current object to the camera. And the last thing here is a 4x4 matrix, which we're going to pull from OpenGL, and this contains the positional data for this specific object that we want to render. So we don't want to go and calculate anything that we don't have to. OpenGL will have this matrix for us already. So we're just going to save it so that when we need to use it later on, we can just extract it from this matrix. Okay, so that's the structure for each object that's going to go inside the container, but the container itself still has to be defined. I'm going to place the container inside of the node.h file, and I'll put it right here in the public section. And as you can see, it's static. So I create a static std vector. So this is an array, in a sense, that's going to hold pointers to alpha objects. Those are those structures which I just showed you a minute ago. And this static object is going to be a pointer to this array, and it's going to be called s_vp alpha objects. Now, anytime you create a static member inside of a class, you have to go and define it outside of the class. So let's go and do that. I'm going to put it inside scene.c++, just right at the very top, since this is where we're really going to be using it. So to define the static variable, we go std : vector of alpha object pointers, and this is a pointer, so we define what we're going to be giving memory for, and the object that we want to give memory for is inside of the node class, so we have to use the scope resolution for node, and then the name of the variable here, so s_vp alpha objects. And we're going to initially set this to null since this pointer hasn't been defined yet. Now, this pointer to all these objects is actually going to point to the real container which we're going to use to store all the items. And that real container is going to get stored inside of the scene class. So let's go inside the scene.h file, and under, let's see here, the private section right at the very bottom, we have all materials, and then we have used for second render pass. So we create a std vector of alpha object pointers, and this time we're not putting a pointer here. This is the actual container which is going to store everything. So I'm calling it m_vp alpha objects. So scene contains this container just like it contains all these other containers, and this container is going to have alpha object pointers. Now, inside of the constructor, I'm going to put it right here. We assign the static pointer in the scene graph to point to the container in this scene class. So what we're doing is we're taking ourselves, the m_vp alpha objects, the address of that, so that gets the pointer value, and we're assigning it to the static guy, which is here. Initially it was null, but now, once we run through this constructor, it's going to point to wherever our container is saved in memory. We can actually go and delete this stuff since we're not going to be using that anymore. We can go into the scene.h file and just clean this up as well. This is from our original method of rendering objects on the screen when we first started working with OpenGL stuff. Okay, so we've set that up. Let's just go and try to build, make sure that everything is okay, and it seems that we got some errors here. Okay, undeclared alpha object pointer. Okay, to fix this, we're inside node.h, but the compiler doesn't know what alpha object is, so we need to go to the top here and create another prototype just as we did before. And let's see if that helps. Oh, looks like that one line of code fixed the 320 some odd errors we saw previously. It's amazing how compilers complain for such a small mistake. Anyway, okay, so we have the containers now set up. Our scene has the main container, and our node shape has, let's see here, node shape. Oh, right. Our node shape is inherited from node, and inside node we have the pointer to that container. So inside node shape, we can now use the container when we need to. That's what we're trying to get at by doing all that extra work a second ago. Okay, now let's take a look at the code to actually store items inside this container. First thing we do is create a pointer to this alpha object. And we're going to call the new operator. So every time we go into this if statement here, we're going to create a new object which we're going to store in the container. If this succeeds successfully, then that means that we have enough memory to allocate for this new object, so then we can start filling in the data. First thing we do is we fill in the pointer to this node shape to be this. And this means ourselves. So whenever we go and call render OpenGL for this specific object, well, the pointer to that specific object is stored inside this keyword this. So we can just set that equal to p shape inside this container which we created up here. Then the next thing we do is we get the model view matrix that's currently stored in OpenGL, and we save it to the 4x4 matrix, which is also defined inside of this alpha object structure. Using that matrix, we can go and calculate the distance that this specific object is to the camera. And the way we do this is, instead of calculating x squared plus y squared plus z squared square rooted, we're going to take just x squared plus y squared plus z squared and leave the square root out. We do this because when we're comparing objects based on distance, it doesn't matter whether you compare the square roots for the actual distance or whether we compare this distance squared. The actual number doesn't really mean anything. It's the comparison between the scale of the item. So for instance, if object 1 is 1 unit away and object 2 is 2 units away, then I don't really need to compare 1 with 2. I could actually compare 1 squared with 2 squared, and it'll still tell me which item is closer to the other item. So that's why we're using this. And as a matter of fact, using a square root to calculate the distance is a waste because it does a lot more computations inside the processor to calculate a square root, but it's not really needed because we don't need the exact distance. We just need a relative distance from one object to another. Now, to get the x and y and z value of a 3D object in space from this model view matrix, you just need to pull out the number that's stored in the 12, 13, and 14 spot of this 4x4 matrix. Now, what do I mean by this? Let's go into PaintShop Pro here and let me draw you a quick diagram of what I mean. Let's clear this off. The 4x4 matrix that OpenGL gives you will look something like this. And the items, all these 4x4 items are stored in an array of 16 values. And the way that they're saved is this is 0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. These top 3x3 items represent the rotation of the object in 3D space. Number 15 should be a 1, so whatever that value should be a 1. This, and this represent the x, the y, and the z translation of the object in 3D space. And these last three numbers are used for something else. So that's what the 16 numbers in this model view matrix mean. We're not interested in anything other than number 12, 13, and 14, since that's the x, y, and z coordinates of our object. So here you can see I'm taking the x value, multiplying it by the x value, adding it to the y multiplied by the y, and then adding it to the z multiplied by the z. So effectively, I'm calculating the distance squared of this current object with respect to the camera. And I'm saving the result inside the object here, which we've created at the very beginning. Then the next thing we do is we need to go and store this new object inside of our container, which is the static value, which we've stored before. But we have to store it in the correct order. So what we do is at the very beginning, we initialize an iterator, which points to the beginning of our container. And we're going to iterate through until we reach the end, going one at a time through each of the items inside the container. We compare the current object's distance to the eye with the current value inside this container's distance to the eye. And if our object's eye is greater than the current value for this container, then we go and insert it. Otherwise, we'll continue on through this for loop. Outside of this for loop, I create a variable that is set to false, so which means we haven't found anything yet inside this container. And then as we're going through, we're looking. If we don't find anything, then be placed when we exit here will still be false. If we do find something, then we set be placed to be true to tell our code down below that we have placed our current item already inside the container. And this is important because of the following fact. We have our container. Let me delete this again. Our container itself, I'll just draw it like this time. So this first item is index 0, and this is index 1, index 2, and so on. So this is going to be the first item inside the container. And let's say we have some numbers in here already, like we've stored some items, like something that's distance 50, something that is 40, 10, 3.2, 0.1, and so on. Now, if our new item's distance is, let's say, 13, first thing we do is we compare this 50 with the 13. So is this greater than this? No. Well, we go to the next item. Compare again. No, it's not greater. Then we go to this item. Oh, 13 is greater than this one. Well, what that means is we want to take this item and place it inside where number 10 is located. As soon as we do that, the code for the container will move all of this stuff down so that our new container will look basically like this. I'll have 50 here, 40, 13, 10, 3.2, and 0.1. So all that kind of shifting around is done for us automatically because we're using the std vector stuff. However, if our value here was 0.01, well, we're going to go through each of these items, right down to the very last one, do the comparison, but each of these are going to fail. So inside of our code here, when we're done this for loop, we will not have placed the current item inside of the container. So at the very end, if we haven't placed the item, we go and push it back onto the container, which effectively places it at the very end. So that's what we do here at the very end. And then we're done. So that's all the sort of container work that we do whenever we're working with a transparent object on the first render pass. Okay. So now the only thing left to do is figure out what to do on the second render pass. Before we go and talk about that, let's just compile this, make sure it is still all okay. Okay, it's great. Now, inside scene.c++, we want to go back inside the update. Okay, we have this switch statement here. So we go in here and we're going to go and start the first render pass because we're setting false. Now, because we want two render passes, we're going to have to replace this code with the following. We first cleared the container that holds all the objects for the second render pass, because we want to make sure every time we go and render, we have a clean container. Then we go and render everything inside of the scene that's opaque or solid on the first render pass, and we store objects for the second render pass. When it finishes this, we're done rendering all the solid objects, and we now have stuff inside of our container. So we go and call GL enable GL blend, since we know we're now going to be rendering transparent objects. We set the model view matrix parameter here, and then we go through our for loop. Inside of the for loop, we create an iterator again, pointing it to the beginning of our container, iterating all the way through to the end, incrementing by 1. We push the model view matrix onto the stack, and we set using GL load matrix F the value of the 4x4 matrix which was stored inside of this container. We then go and call the current object's shape nodes render OpenGL with a true. And remember, this true now represents we're rendering on the second render pass. So inside of the render OpenGL, we're going to go and actually render things that are transparent. And then once we finish that, we go and pop the matrix off. And then we go through this all the way until we've rendered everything inside this container. After that, we just go and call GL disable GL blend since we're done with the transparent objects, and then we exit. We could optimize this slightly by checking to see if there are any objects inside this container before we do this stuff, but that's neither here nor there, so I just leave it like so. One thing we haven't implemented just yet is this delete all alpha objects. So let's go and do that, and after that I think we're done. Inside of the scene.h we need to go and place a prototype for the function here. Delete all alpha objects. It takes no parameters and it returns nothing. And let's put this function right underneath delete all materials. Oh, that's assigned materials. Delete all materials. Actually, let's put it, right underneath assigned materials. So right before we go and initialize. So delete all alpha objects. It's just going to go through the container one at a time, deleting everything that's inside there. And then we go and call clear. Now notice that the way that I delete this is not using the iterator, and you can actually interchange. Because we're using std vectors, you can reference items inside of the container this way, or you can use the iterator, whichever one is more comfortable to you. I sometimes use this technique, sometimes I'll use the other technique with the iterator. It really makes no difference. So if you want to interchange, that's fine. I just wanted to show you that you can do this as well, and it works exactly the same way as if using an iterator. Alright, let's go and render, or build this first, make sure everything's okay, and run it. Okay, now notice when we look through this window, we see both boxes. When we look through this window, we see both boxes. And when we look through this window, we see both boxes. Now, OpenGL is doing all the work for us. It's basically rendering our objects according to the order that they are on the screen with respect to the camera. As we move, the order in which these objects render gets switched so that the furthest object gets rendered first and the closest object gets rendered last. So there we go. Not too bad. A lot of math and a lot of detail you have to really understand on what OpenGL is doing behind the scenes for you to be able to implement this. But now that it's implemented, if you don't want to worry about it, really, you don't have to. It's pretty robust. Feel free to play around with it. Now, whenever you have transparent objects overlapping other objects or even other transparent objects, everything should be rendered on the screen correctly. One downfall, though, our objects are always referenced with respect to their origin. And when we're doing this distance calculation only ever happens with respect to this origin, not with respect to every single vertex inside of the objects. So if you do have closely meshed small transparent objects, you may still find a problem. But if you're doing something like that, expect there to be problems because you shouldn't be placing small transparent objects so close together. If you want to have a whole bunch of small transparent objects, make them into one big mesh, and then you're not going to have that problem. But if you have them as individual objects rendered really close to one another, you could still have some problems. Okay, so I hope this was informative. I know I probably lost a few people in terms of what I did, but go through the video. You have the luxury of hitting the rewind button and playing it again to hopefully get a better feel for what it is that I'm trying to do and how it is that the code is actually working. if you have any questions about any specific video, just feel free to go to the website, and underneath the community section, I always create a new thread for any new video section that I create. So if there are specific questions that you want to ask on a specific video, that's a great place to go and do it, because all other people that are watching these videos, if they have questions, they can go and comment on them there as well. The thread for this current video is not up yet because I still have yet to encode the video and compress it and all that other stuff. But once I finish that, you'll find a game dev VMK 27 here, which will cover this current video.